Hey guys, what's up? Welcome back to the Rocket Hub. My name is Philip, and today I present you the beginner's guide to Starship. This video acts as some kind of glossary for every bit of content around Starship on this channel. You will find a quick explanation of every single design aspect of Starship in this guide, but I have linked all the more extensive videos in the respective chapters. With that said, let's start. Since at least 2016, SpaceX is putting serious effort in the development of Starship, a fully reusable two-stage launch vehicle set to revolutionize spaceflight. But just as revolutionary as its ambitions is the vehicle's design and size. The entire Starship system, consisting of a Super Heavy booster and a Starship upper stage acting as a spacecraft at the same time, reaches an astonishing height of almost 120 meters while having a diameter of 9 meters. Starship, the actual spacecraft, stands at 50 meters tall and is able to carry more than 100 tons of cargo to low Earth orbit. The Super Heavy booster makes up the other 70 meters, although it's a bit shorter, standing at about 69.5 meters. The entire system has a takeoff weight of approximately 5,000 tons, making it the largest and heaviest rocket of all time. The entire vehicle is built from rings of the 304L stainless steel alloy with a material thickness of 4 millimeters with internal support structures. Starship's design goals are rapid reusability, reliability, and maximizing payload mass. Plans for the system include missions to low Earth orbit, point-to-point travel, lunar missions, and crewed Mars missions. To achieve these ambitious goals, SpaceX needs a powerhouse of an engine to propel Starship upwards. The solution is called Raptor. Raptor is the world's first full-flow stage combustion cycle engine to power a rocket and at the same time the first methane-burning engine to be flown. This rather unusual choice of fuel and combustion cycle enables Raptor higher reusability, efficiency, and lower material stresses, but it also makes the engine a lot more complex. The Raptor engine produces a thrust output of 185 tons for Raptor 1 and around 230 tons for Raptor 2, while having a specific impulse of 330 seconds at sea level and 378 seconds in the vacuum of space. 33 Raptor engines power the first stage, the Super Heavy booster, generating a total of 7,500 tons of thrust, more than twice as much as the Saturn V. The center 13 engines of the Super Heavy have the ability to gimbal, while the outer 20, sometimes also referred as Raptor boost engines, are fixed into position. Starship currently features another 3 sea-level engines and 3 vacuum-optimized engines with larger nozzles for in-space propulsion. For control authority over the vehicle, Starship is able to gimbal the center engines. In the future, Starship is expected to receive another 3 vacuum engines, bringing the total number of engines up to 9, meaning the full Starship Super Heavy system features 42 Raptor engines. Since the Raptor engine is one of the most fascinating pieces of spaceflight technology that we possess, I have dedicated a 1.5 hour long video series on it, which is certainly worth watching if you're interested in this particular engine. The Starship system is set to be fully and rapidly reusable, meaning many flights in short succession without major refurbishment operations in between. To achieve this, multiple unique systems are needed to bring the Super Heavy boosters and Starships back down to Earth undamaged. The Super Heavy booster uses a series of engine reignitions to reorientate itself and cancel out velocity. The so-called boost back burn happens right after stage separation and is used to eliminate horizontal movement and accelerate in the opposite direction, aiming for return to the launch site. Later on, the landing burn slows the vehicle down to 0 for touchdown on the Mechazilla system, which we will take a look at later in the video. When in space, the booster's attitude is controlled by venting of excess gas, acting in a similar way as the typical RCS thrusters. Once the venting becomes inefficient due to re-entering the atmosphere, 4 unevenly distributed grid fins at the top of the booster take over control of the vehicle. By changing their angle relative to the airflow, these grid fins are able to create lift and therefore change the orientation and direction of the falling booster while also stabilizing it. Starship's reusability enabling design aspects are quite a bit more prominent than the Super Heavies. The entire windward side of the vehicle is covered by a thermal soak heat shield made of special ceramic which is highly heat resistant. During re-entry, the produced heat is first absorbed and later slowly radiated away. If you want to know a bit more about heat shields, I've got you covered with my 20-minute deep dive on that topic where I explain the different types of heat shields, including the one of Starship, in a more detailed fashion. Other than the Super Heavy, Starship doesn't enter the atmosphere engines first. It falls through the air belly first, meaning the engines are oriented horizontal and can provide any control authority. During the so-called belly flop maneuver, Starship is controlled by 4 flaps which can be extended or retracted to either increase or decrease the surface area relative to the airflow and thus create more or less drag. This leads to a change in the terminal velocity of the different parts of Starship, so the flaps can either lift the nose or push it down, as well as turn it to the left or the right. And again, there already is an in-depth video uploaded on my channel in which I explain how exactly this all works and even demonstrate it with some simple 3D models. But aerodynamic surfaces and the heat shield still isn't everything in terms of reusability related features of Starship. After all, the vehicle lands upright on its base but falls towards the landing site belly first, so it has to reorientate itself shortly before landing. To achieve a vertical landing, the engines start up in mid-air and gimbal to push Starship back into a vertical position. But as crazy as the design of the Starship on the outside might be, the more unusual it gets on the inside. To house all the propellant and feed up to 42 engines, you need a lot of special systems to manage all the processes to enable the rocket to launch and later on land. The 2 propellants, liquid methane and oxygen, are stored in large tanks in both the booster and the ship. These tanks utilize the vehicle's external hull as the tank wall and are separated by a single common dome, a design only possible when using propellants with similar storage temperature such as methane and oxygen. The operating pressure of around 6 to 8 bar is established by autogenous pressurization, meaning that excess gas generated by the combustion process is used to repressurize the emptier tanks. To feed liquid methane from the upper tank to the thrust manifold at the bottom, long downcomer pipes run through the entire length of the oxygen tanks down to the engines. The engines themselves receive their methane fuel through these pipes, while the oxygen is drawn directly from the oxygen tank, of which the thrust dome is the lower edge. To ensure the propellant flow during the belly flop maneuver needed for the Starship's landing burn, Starship possesses 2 additional header tanks located in the nose cone, and these are connected with the thrust dome by own downcomer pipes running along the side of the vehicle. Starship isn't just Starship. There will be multiple variants of the spacecraft for different purposes. These variants only exist for Starship though, they are all going to be launched on one and the same Super Heavy design. Currently, the only Starships we have are the prototype ships, which don't really count as a variant since they are prototypes after all. First of all, there is the cargo freighter variant, which is likely the first one we are going to see becoming reality. The cargo Starship looks pretty much like the orbital prototypes, with the one big difference of featuring a proper payload bay and door. We don't know how large this door is going to be or how it might look like, but the most likely outcome is what is shown in these beautiful renders by Eric on Twitter. Starship's payload capacity is expected to be around 150 tons and a payload volume of almost 1000 cubic meters. The second variant of Starship is the tanker variant. From the outside, the tanker will probably look almost identical to the cargo variant, but will lack the payload door. Instead, these tankers are going to feature additional tank capacity rather than payload space and transport liquid methane and oxygen. Once in orbit, these tankers will dock with other starships or potential orbital propellant depots to refill their propellant residuals for further missions. In addition to the tanker variant, there will be an orbital fuel depot variant. Other than the tankers, these starships aren't supposed to return to Earth but stay in space once launched. That's why the orbital depot variant isn't equipped with a heat shield or aerodynamic surfaces. To fit more propellant into the depot, its top section is stretched compared to other starships. Operating in low Earth orbit, these depots are regularly filled by tanker starships and store the delivered propellant for a long time. Crewed starships or freighters headed for deep space can dock with these depots to accelerate their refilling operations. The fourth variant we know of is the crewed version of Starship with fully developed life support systems, a well overthought interior, and deployable solar sails for electrical power. These ships will be used to transport anywhere from a few up to 100 passengers into low Earth orbit, the International Space Station, the Moon, or even to Mars. Some of these craft will be equipped with landing legs for propulsive landing on other celestial bodies. And the last variant that we know is certainly going to be built is the NASA Human Landing System. In 2021, NASA selected Starship to be their lunar lander for the Artemis program. To bring 2 to 4 astronauts to the surface of the Moon, this Starship will lack a heat shield and flaps since it never re-enters the atmosphere and therefore doesn't need any re-entry equipment. The HLS variant is going to feature deployable landing legs, docking ports, and lifts to lower equipment from the payload space to the surface of the Moon, and maybe even additional thrusters to support a lunar landing. Starship will also be used for point-to-point transportation as a competitor for airliners, which may require an own variant of the crewed ship as well. These ships would most likely be adapted for suborbital passenger flight and could fit more than 400 passengers. In the future, there may be also a stripped-down deep space variant without re-entry systems or recoverable payload door for missions into the depths of the solar system. These ships won't be reused and would only exist for bringing probes to the outer planet or even act as a highly maneuverable space telescope. Any sufficiently advanced launch vehicle needs special ground infrastructure to support operations. But in case of Starship, these ground systems don't just include a pad and the good old strongback. Starship operates with the help of an advanced launch support tower with multiple arms called the Mechazilla. It features a quick disconnect arm that grabs around the top of the Super Heavy like a claw and connects to the QD panel of the ship. The second pair of arms are known as chopsticks and are what gives the Mechazilla structure its name and function. These chopsticks are what catches the Super Heavy out of the air and lifts the Starship up when conducting a full stack. Additionally to the tower, the launch mount itself acts as the quick disconnect host for a Super Heavy booster, which is suspended in the middle and held up by clamps pressing against its hull. Furthermore, the launch mount possesses 20 additional QD ports for the Raptor boost engines on the booster. At engine ignition, the cold gas used to spin the turbopumps of the Raptors is provided by the launch mount, since the Raptor boost engine isn't capable of restarting on its own. And just in case you want to know more about Mechazilla, I've got you covered on this topic as well. A revolutionary vehicle like Starship has to break with many conventions of traditional rocketry to reach its ambitious goals. New technologies in propulsion, reusability efforts, and vehicle design are needed to create the world's first fully reusable launch vehicle. A new engine, new materials, advanced heat shields, the list goes on and on. This video should give anyone from complete newcomers to spaceflight nerds like myself a decent overview of the rocket of the future. I've only touched on the various specific topics in this video, but as I said, feel free to watch on and dive deeper into all of Starship's secrets. And that's it for the beginner's guide on Starship. Let me know in the comments if you enjoyed the video, and if you did so, why don't you hit the like button and subscribe to the Rocket Shop. Thank you if you do so. We see ourselves in the next video, and until then, I'm out. Cheers!